Hello, everyone. My name is Andres, and I'm here with IESVE, the Building Performance Software. About IES a little bit, we are the home to the largest building analytics team in the world. We've been in the market of climate tech for about 30 years and building analysis experience. We have a global team with local knowledge. We have team in Canada and the US, working closely with the municipalities and the most leading energy codes in both of the countries to make sure that those requirements around new buildings and retrofits are being translated into the capabilities of our software. We have helped in more than 3,000 consulting projects, and currently we have more than 18,000 software users around the world. Good fact about our software is that currently more than 1.5 million buildings in the world have been modeled using our technology. So that's I thought it was nice to mention. In addition to that, the engine that we use for simulation, it's proprietary. We are owners of the world-leading building simulation engine, Apache, and that's the one that we use to process all the dynamic simulations in our software. I'm going to talk about 3 or 4 main features that I thought would be relevant to this event. One of them is using parametric simulation. It's a design option comparison that you can use to, that is essentially early stage design and retrofit, where you can choose different variables to change across the design opportunities in your project. And based on what your metric or performance are, like EY, GHEI, then you can choose the best combination of design strategies that will lead you to that performance of your choosing. This allows you to model thousands of permutation runs in one single model, and then choose the path or the top 3 paths that are more likely to bring you to success. The results are presented through an interactive and shareable report. This report is known as a parallel coordinates plot that you can use to sort of filter down and pinpoint which of these design strategies are the best for your project. For the parametric setup, the users can vary a wide range of inputs from the envelope constructions, geometry, internal gains, HVAC assumptions, and also on-site renewables like the amount of PV area that is available. And there are some newer inputs that we added through the past year. In this case, they're highlighted here, like envelope templates. Now we have TEDI as one of the outputs that you can use, to understand how is that energy demand intensity for your project. You can also add location and also future weather files to start comparing how a specific set of design strategies will perform under different conditions for future weather. You can also review cost and carbon, and this gives you an overall just a clearer picture of the thermal efficiency of your project. Altogether, this allows you to assess energy emissions and demand impacts within a single and consistent workflow. Another feature that we added recently is our climate assessment report. This report contains visuals that are designed to quickly surface the key climate drivers so teams can identify what really matters for sizing and design conditions without digging through any raw data. Although you can ultimately build a full simulation model, all you need to generate this report is a standard EPW weather file that you can export to multiple formats like HTML or PDF. This unified report contains a full 8760 weather data set alongside ASHRAE design days, PV potential, hourly carbon emissions data, and everything is in one place. It bridges the design assist and engineering grade reporting with clear visuals and narrative explanations that make the data accessible across the whole project team. You will get a report with 23 images, and each of them will identify key design drivers in the different climate averages and extremes. With the increasing importance of renewable energy systems and storage in our new projects, the software has the capabilities to also model these. You can model solar PV, solar hot water, wind, battery storage, now recently as well EV vehicles. And you can use that information to just populate the model and make sure your building performance simulation is accounting for all of these additional variables and factors that are now of increasing importance. One of the things that mainly differentiate us from other simulation softwares in the industry is that we have something called navigators. And navigators are user workflows or guided workflows for the users that has, that have one objective, and that one is code compliance automation. In the case for Canada, we have been approved by NRCan to have this navigator for NSEV 2011, 2015, 2017, and 2020, which is the latest code that it has been adopted in some of the provinces already. So if you're working in a project that needs to comply with these Canadian regulation, and you need to create a reference building and a proposed building and compare how the two, how the proposed compares to the reference building, you can use our navigators to have that process automated from beginning to end and give you the information that you need to present to the authorities to make sure that the project gets approved. One of the latest features we added is also thermal bridging. Now you can implement thermal bridging in a dynamic simulation by using our thermal bridging features. There are several mechanisms that you can implement thermal bridging in the software. You can add a clear field, linear transmittances, random transmittances if it's area or linear or point transmittance in the thermal bridge. And the methods that are supported are the most widely used internationally, like the ISO 14683 and ISO 90.1. Method, and for Canada as well, we have the BTBG guide method is also embedded here. That's everything I wanted to share with you. Thank you so much, and if you have any questions, feel free to message me or my colleague at the emails on the screen. Thanks.